Okay. All right. So, hi everybody. I'm Toma. I'm a researcher, manager, and consultant in medical AI. And I'll talk to you today about how AI is transforming healthcare and the change that we're seeing and the future that's coming ahead. Please feel free to mark comments in the chat or burst in if you can, if you have any questions or answers. So the talk today is going to be in the theme of science fiction, or more specifically 1960s science fiction. So if you're a science fiction fan, this is for you. If not, tough luck. So we'll talk about where we are today, not just in healthcare, but in technology in general, and then compare that to healthcare versus the 60s prediction, where we want to go, why healthcare is a bit lagging behind, but I will argue that this is going to change, and this is the next frontier. So hopefully I'll convince you that we have the ingredients to make the next breakthrough in healthcare. So we'll start with a short clip of 1960s film, and let me know if you know which movie this is. This talks about how they predicted communication will be like in the future, which is now in the present.
Well, Mr. Travis, please come to
Hello. How are you, Squirt? What are you doing? Where's Mommy?
Gone to shopping.
All right, so this is a film from the 60s predicting how we'll be talking today. Anybody know which film? Yeah, so this is Stanley Kubrick Space Odyssey, and this is basically their vision is now present, and this is how I'm talking to you today in this conversation. And we've actually gone beyond that. We have transcription, translating of the conversations, different languages. We can also make silly skins and videos during the conversation. So that's communication. Another idea that they had was that we will be assisted by AI assistants that will help us manage our life. For example, the HAL 9000, which it was the computer or the machine that the astronauts talked to on the Space Odyssey spaceship. And it was there to help them manage their tasks and also talk to them. And so that didn't end so well in the movie, but here they did have a pretty good prediction, because we can all see, if not now, then in the next few years, agents that will help us or do stuff themselves, drive the cars, and also manage our home. I was just on a trip to China, and you go into the hotel, and there's a AI assistant manager you talk to, especially if you know Chinese. This is very good. So pretty good predictions in healthcare. What they had is, if anybody knows what this is a tricorder from the Star Trek film. And this machine, you can just hover over somebody and it tells you automatically all its vital signs, all the person or the alien's vital signs, and how he's feeling, how he's going to feel, and what should be done about that just by hovering over him. I'll show a short movie.
Her heart and lungs are seriously compromised and her kidneys are failing. The creature is also secreting some kind of paralyzing agent into her bloodstream.
All of the systems in her body have elevated readings. Take her to sick bay.
All right, so you saw the tricorder can really go over any person and say exactly what's going on with him. And are we there yet? Well, not exactly, but before we talk about are we there, we can take the concept of the tricorder and think what we want out of the future medicine. So we want to have something that will know the patient's condition at each time, instantly, cheap, non-invasive diagnosis, and it will know exactly what the person is suffering from just by hovering over it. And not only will he be able to diagnose, he will also give a prognosis, meaning he will or it will allow us to understand what's going to happen to the patient and what are the optional directions. It will also suggest the right treatment for the patient. So if there are multiple treatments, for example, cancer patient, should he go to chemotherapy or other options? And it will also be proactive and act before we get sick. So it's not just sick care, it will actually be healthcare and give us warning signs of when we're going to be sick. And we don't have to wait until we're sick. And also tell us which directions we need to go to have a healthy, long life. So that's what we want out of healthcare. And if anybody has tried to book a recent appointment with a doctor to diagnose something, he knows we're not quite there yet. Also, this is recognized, Washington Post, 20% of patients with serious conditions are misdiagnosed. The third largest cause of death in the United States is medical errors. So we don't know how to diagnose well. We don't know how to treat well enough. And we're also, as the population is getting older, we also have a problem of not enough doctors. So we need AI's help here. And this is the direction that I think everybody understands that we're going. So how are we going to accomplish this transformation in healthcare? As Albert Einstein said, if you want to know the future, look at the past. So let's take the examples that I talked to you before about communication and particularly smart assistants and AI. So to allow this breakthrough, we need three fundamental ingredients that had to happen. And then we'll talk about why it is a bit more difficult in healthcare, but why we are making progress. So the first ingredient is data. So the algorithms that we have now for building these beautiful agents, ChatGPT, etc., they have been trained on a lot of data. And that was possible because we have the World Wide Web in which we can take massive amounts of data, store them and organize them, and feed it to the hungry machines. The machines and algorithms, the machines need sophisticated algorithms to be trained. And that's the evolution of the field of data science and AI for the past, since the 60s. And we had the deep learning machines, algorithms that made a revolution in vision. And we also have the transformers now, which have changed the way we work with text, NLP. And that's the second ingredient. And the third ingredient is hardware or compute. We needed to develop the right hardware to do this massive amount of calculations to parallel computing in GPU. So all these things had to happen for the revolution that occurred. And in healthcare, I will explain a bit, I will go through these three and I will explain the challenges and the solutions. So the first challenge in healthcare is the data. And when we talk about the data, there's a few issues. First of all, when you look at the patient's health data, it's a bit of a sophisticated and complex data set because it is basically a timeline of the person's life. And then every once in a while, you have a specific data point. And the data points are different. There is an encounter that you have with your doctor. There is a lab tests, blood tests. There is procedures, diagnosis, medical notes, etc. And this information can be in text, it could be in images, it could be in medical codes, and different types of information. So we need to build a system of how to store and save this kind of information, not just a physical system, but a theoretical framework for how to work with these. And also there's a lot of missing data. So you don't have a recording of all the metrics for you every day, every hour, so that we know. For example, if you want to map your heart with an EKG, you do that maybe once in 5 years. And how's your heart doing between these points? We would like to know. And that's not available. So it's actually much more missing data than real data in this case. And most of the algorithms that we have for vision, etc., are not used to this kind of missing data. So those are two problems. And then the third problem is that for privacy and security, for good reasons, all our medical information is not such easily acquired on the web. And we have to have security and privacy concerns dealt with. And so we don't have this massive amount of data that's available for these models to train in a format that is organized. In the US, there's thousands of medical centers. They all store that in a different format and the different information, different types of medical information. And in Israel, the situation is a bit better, but still there is a lack of standardization and a large cohort that can be fed to these hungry models. So those are three problems with the data in healthcare, but they are being tackled. So both government and big tech are making strong efforts to develop these kind of data sets in the UK, in Europe, and in the US. A large amount of data sets with hundreds of tens and hundreds of millions of de-identified information of patients. And this is the first step forward. So that deals with an organized big data set that's for the models. The other thing is regarding missing data. So the things that we could do in the past only at the hospital are now available at home. So for example, just from your smartphone camera, you can detect your heart health, your heart rate, your blood pressure. You can detect mood disorders following a video of your from your smartphone. Neurological disorders, you can look at your skin, respiratory, your eyes. So there's a lot of things that you can do now that are available at home just from the camera. The microphone itself, so listening to your voice can also help. Of course, all these use machine learning algorithms, which you will learn to do in the programs. So your microphone is a very interesting piece of information that can be used to also detect and classify respiratory issues, mental health, Parkinson, fatigue, stress, sleep. So that's just your microphone. We also have wearable, whether it's rings, patches, so stuff like EKG that you could in the past do only at the hospital. You have medical grade EKG you can put on a patch and wear at home. You can take a ring, and everything that used to be available in hospitals now not everything, but a lot is now available at home. So you can kind of like fill in the missing pieces slowly. Same thing for neural recordings, whether it's EEG to map your brain activity can be done at home. And even the MRI scanners are getting smaller and more remote. So you can go to, in the future, you can go to your, I don't know, a pharmacy and do a MRI scan that will be analyzed by an AI physician and tell you your situation. So you can do that, every week or every month, and you'll have a better picture of where you're going. Okay, so we talked about the data. And the data, there are already big data sources, and there are ways to fill in the missing data with measurements at home. In addition, there have been advances in terms of algorithms. So you want to take your time flow of medical events, and you need to work with that to build a predictive model. So here's just one example of a transformer EHR. EHR stands for electronic health records. You take your visits, and each medical event can also be recorded with a medical code. So for example, E11.9 means that you were diagnosed with diabetes, or your lab measurements was this and that. So this is sort of a medical language, and you can treat that same as you would a natural language and build a predictive model on that, feed that to the models with a few alternations. You need the time embedding, etc. But you can use this technology to work with the medical codes and predict, for example, what will happen to you on your next doctor visit. And multiple works have shown that, and by the way, you can use this base models for multiple applications, and once you have the embeddings that represent the medical state of the patient, and you can predict, for example, lab results or X-rays findings and a bunch of different things. And they show in the multiple works that this is advantageous to the previous models. So the CLMBR, the orange is better in area under the ROC curve. So higher up on this. These are stuff you will learn in our courses. Okay, so that's one example. Another example from the work that I did when I worked at Hello Heart. So we have data from electronic health records of tens of thousands of patients, and we can use this kind of embeddings that were used in the paper that we showed to predict who is going to have a heart attack or stroke, and we can do that better using these technologies and algorithms better than what was previously available. I spoke mostly about diagnosis and prognosis. There is also a full field that of treatment. So how do we decide the optimal treatment? I won't go into this too much, but we want to do personalized medicine. Everybody needs their special treatment. What the drug that is right for me is not for you, and vice versa. Theoretically, if we want to fit the right drug for each one of us, we need a time machine, Back to the Future time machine that will take drug A, see what happens, go back in time, take drug B. We don't have the time machine, but there are algorithms that are simulating this time machine through recommendation systems and causal analysis. And just like you get a recommendation on the movie that you want to see, you will get a recommendation on the treatment that is for you. And the last thing I want to talk about is hardware. So hardware, unfortunately, in my mind, too much effort has been spent on optimizing likes in social media, and this is you can observe this in the Jimmy Kimmel as he explains what a smartphone is to Doc and Marty.
How we document important life events now. Yeah.
Is this some sort of portable telephone communication device?
Well, no, actually, this is the best thing about the future. It's called a smartphone.
Great Scott. It's a tiny supercomputer.
Yeah. It is. It's like,
This must allow astrophysicists to triangulate complex equations
yeah.
in real
Well,
time.
I guess it probably could do that, but mainly we use it to send little smiley faces to each other. Pictures of eggplants, that sort of thing. So it's not really what we use it for.
All right, so that's the past, but actually this is also changing. Big tech is investing a lot, spending a lot of its infrastructure on medical applications. And one example is the Nobel Prize for Google DeepMind for developing the method for protein folding prediction. So this is changing, and the investment in healthcare is on the rise and predicted to be further on the rise. So to summarize, I think we have the necessary ingredients in terms of data, algorithms, and hardware to make the next revolution in healthcare. And using the vision of tricorder, make that into a reality. And that is it. Thank you, and I invite you to be part of the revolution.
Thank you very much. If you have any questions, this will be a great time to ask them. You can ask them in chat, and then if not, we'll move to Serge. Questions, anybody? Okay, so Serge, I believe